I'm Dongwook from Cornell University, and today I will talk about how we sense tablet grasp and micromobility for supporting active reading. This work has been done as my Microsoft research internship under supervision of Hinckley and in collaboration with all the authors in the list. The most primitive way we are interacting with physical objects around us is through physical manipulation. And physical manipulation gives a good insight for designing new interaction techniques because it reveals people's intention under certain context. One good example task that shows how physical manipulation reveals people's intention is active reading. Active reading is an activity for collecting knowledge through the reading proactively. For example, people navigate the book in non-linear fashion by flipping through the book or thumbing, or they lay out document to conduct information across the multiple sources of information. And they also collaboratively working together with other people on the same document. And it is so important to support effective user interface for the active reading because we want to put user into the flow of the reading, not putting the UI in the way of users' reading activity. Thankfully, active reading is benefiting from the materiality of the book pages, and they're full of the embodied interaction that we can take away as a source of information that we can use for designing new interaction techniques. For example, people flip through the book, lift the book for a closer look, or lay out document in a multiple way in space, or they orient the book toward the other. One theory that explains how physical manipulation reveals people's attention is micromobility. Micromobility is a orienting and repositioning of the physical artifact under a certain collaboration context. And motivation of our study was the realization that there's always hand grips coming into play when there's a micromobility. And here's the one exemplary interaction technique we developed. So I grasp the device and pass it to the other by rotating it. And you can see the device captured this hand of context and changed its mode to the guest profile. And you can see that here are the grasp and micromobility undertaken altogether as an alternatively changing grasp between the two people and the rotating motion. And you can also see that one application is changing the set of the ink and their color. So the user was red, and as the user put the device back to the original user, the ink set turned into the blue set. Because we knew too little about how and why people undertake such grasp and micromobility interaction, we decided to perform an observational study for capturing naturally occurring grasp and micromobility in document work. So we brought user into the lab, dialed the user, and let them do a presentation, collaboration, or competition tasks. Because we really wanted to capture the naturally occurring behavior without digital biases, such as touchscreen avoidance grasp behavior, we used acrylic tablet mockups instead of the digital tablet. And here's the list of the interaction technique, list of the observational behavior we captured from this observational study. So first one is the lateral swing for face-to-face handoff. And you can see that to put the device's orientation right for the user, right for the recipient on the face-to-face side, how people grasp alternatively the device and then rotate it with the lateral swing, frisbee-like motion. And here's the individual level grasp plus micromobility interaction that we observed. So when users are deeply engaged into the reading activity, they grasp the device on the side edges with two hands and slightly pull the device to their eye orientation and then fill up their viewing angle and viewing area with the content itself without having peripheral distraction. And when they want to focus on a line of text, As you can see, she is putting her thumb on the line and pulling the part closer to focus on that part. And you can see how interplay between grasp and micromobility is manifesting the different level of the user attention toward the different part of the contents. So there was the observational finding about grasp plus micromobility. And because there was no existing device that can capture both of a signal from the user, we had to build an infrastructure to capture the grasp and micromobility interactions. So we used a standard tablet covered by the custom capacitive sensing array, which is 44 by 26 array, that covers entire back and side edges of the tablet. And there's in the middle, as you can see, inertial sensor set is capturing 3 degrees of freedom of the movement that is exerted on the device. For the capturing multiple hands with multiple types, we first denoised this raw capacitive signal, and then segmented them with the geometrical features, and then stream the features into the classifier and get out the multiple types of the grasp. For example, thumbing on the right part of the tablet, or you're putting your thumb out of the screen, or you can wrap the device. So to take a look at the multiple types of the grasp, please take a look at our paper. And you can see the demo of actual grasping interaction. So here's the wrapping, and on the right side there was thumbing, and also here's the movement captured by the device. To design grasp plus micromobility interaction, we defined a new interaction space. So first one is single user, single device technique that we try to accommodate users' differing engagement level. And for the multiple user, single device technique, we try to capture collaboration context between a dyad of user. And for the single user, multiple device technique, we try to capture how user conduct different information across the multiple device. Multi-user and multiple device technique has been investigated by the Marcel et al., a focus on the micromobility, but we left the grasp plus micromobility aspect of that space for the future work. The first interaction technique was inspired by observation on face-to-face handoff interaction. And one specific grasp, which was really popular among the people, was the top grasp. This is because people want to grasp the top to put the device in the right orientation with a single frisbee-like rotating motion to the user on the opposite side. And we take this interaction to the digital realm, and as you can see, I grasp the top and rotating it to the other user. You can see the device is capturing different handoff context. And you can see how grasp and micromobility is combined in this interaction. And let's take a detailed look on the technical detail. And you can see on the left top side, alternatively changing grasp is captured by the device. And top down, yeah. Next technique is to accommodate immersive reading status of the user. And this was inspired by the bimanual symmetric grasp in the observational study. This technique, when user constantly grasp the side edges of the device, it slightly zooms the contents in without having the peripheral distractions such as menus or icons. And you can see how grasp and micromobility interaction is robustly supporting a user's heightened level of attention toward the device. The next interaction was inspired by a finger bookmarking and the tip to flip back to get back to the bookmarked page. And you can see here our interaction technique that when user constantly holding side edge, it bookmark the book with a dog ear, and then you can move around the multiple pages. And then when you want to get back, you first tip the device and pick the bookmarked page and tap to get back to that page. And if you want to remain in the current reading place, then you can simply level the device back to the original orientation without tapping the side. And you can see how combination of grasp and movement of the device is accommodating complicated navigational behavior in a natural manner. The final interaction, which is a single-user, multiple-device technique, has been inspired by the thumbing behavior. So as you can see here, when user constantly putting finger onto the device with content, it echoes the contents to the working tablet, and user can archive multiple graphical links to the working tablet. And when after you capture all the graphical links, when you want to get back to the original contents among the multiple devices, how would you select the device? It's naturally occurring grasp interaction that we used. So user can designate which device he wants to see the contents by grasping it or tilting it. And you can see how combination of grasp and micromobility is making this capturing of different attention level more robust and comprehensive. Here are evaluation results from our preliminary study. User really liked and felt like it was easy to learn the interaction technique, especially because the familiarity of the naturally occurring grasp and micromobility interaction that is transferred to the digital realm. And also, it was interesting to observe that our interaction technique can capture a variety of interaction. For example, the interaction technique we had in mind when first designing the technique was that when you hand off the device, the giver is rotating it like frisbee. But as you can see in this example, this giver of the device is just passing the device without rotating it, but letting the recipient rotate it by himself. But our interaction technique that combines grasp and micromobility can capture this variety of the technique because we try to capture the context of the handoff behavior, not asking user to do a certain steps of the gesture that is combined with the grasp and micromobility in sequence. However, not all of the variants has been captured. For example, when a user is passing the device to the sideway without rotating it, when they're standing side by side, our interaction couldn't capture that. There can be two different ways to mitigate these false negatives. The first one is making our recognition technique more comprehensive by flooding more data and variety of the cases into our recognition engine. And the other way is to intentionally not recognize it by design, but we are just leaving latitude for complementary natural expression and communication so that they can deal with these exceptions by using nuanced social interaction between them. To conclude, we show that capturing naturally occurring grasp plus micromobility behavior can provide a mutually reinforcing signal of underlying user context. For that, we performed an observation study with new findings, and we built a new infrastructure system that can capture that. We also designed a new interaction technique with new design space. And as a final remark, it was not just about grasp, nor just about movements of device, but it was a combination of grasp and micromobility that really made this contextual sensing more robust and comprehensive. Thank you, and I'll be happy to answer your question.
We have time for a few questions. I'll start. Yeah, great. Well, he's getting the microphone. How did people's touch avoidance on the tablets change how they? How did people's avoiding touching the screen change how their grasp was?
Yes. In the previous study, it's known that people didn't want to intrude into the touch unintentionally, so they tried to put their thumb outside of the device. And for the weight balancing purpose, they're putting their palm a little bit more into the device. So that's quite naturally occurring behavior, unintentionally, but to avoid unintentional touches on the touch screens.
Hi, I'm Yoon from Carnegie Mellon. Very brilliant work. So I have a question. If I remember correctly, you use a capacitive sensor matrix, and the number of it is 44 by 28?
26.
26,
yes.
Yeah. So is there any specific reason for that number? What is your bottleneck? Can we go even higher resolution? And another question, if we can go higher resolution, what other applications can you imagine to be integrated into that sensor array?
I think that's a great question. So if you think about 44 by 26, in terms of the imaging, it's quite low resolution. But if you think about it as a capacitive sensor, it's more than thousands of the elements. So it's really, really dense as a capacitive sensing technique that can capture multiple hands interacting on the same device. It was more of the engineering choice to make it as dense as enough with our team's available hardware resources. And if we can make it much more higher resolution with advanced technique, it would be awesome if we can implement multiple different interactions, such as swiping gesture. For example, think about the bookmarking technique with the swiping gesture, and you can make it more robust enough to sense in different way. And you can also sense the pressure by taking a look at the size of the touches as well. There could be another dimension that we can expand on if we have multiple resolution, higher resolution of the device. Thank you.
I have another question here.
I'm Andrea from Google. Thanks very much for the talk. So I have a question about, a lot of your examples show the device in a landscape orientation. Would that, I mean, if you rotated it, would you have a lot, I mean, would you expect the same behavior that you saw?
Actually, our behavioral study employed a different orientation of device together. Okay. So we did a landscape mode and this, what is that, portrait mode as well.
Yeah, so and even the two-handed would sort of just naturally look the same.
So for the weight balancing, there was a slight differences. For example, when users are reading on a portrait mode, yeah, they didn't have much of the requirement for holding the device using both hands. Yeah. But for the landscape mode, they had more requirement to do that. Cool. So there can be a really different contextual information to make it more robust. That's a great question, I think.
And do you think that it would be the same if the device was smaller, like, you know, a smaller phone?
Great question as well. Okay. So our observation study actually had the small tablet as well. Yeah, and that has a lot of the flexibility of interaction. For example, you can hold the grasp using your single hand, like this, just like smartphone. And there could be another variety of the interaction using a phone. Thank you.
So I've got a question. I'm curious if there are cultural differences between the way that people hand objects like that back and forth. Because certainly in Asian countries, giving a business card is done with two hands.
Yes. I think this the one? Oh, no. Yeah. Actually, we did observe that kind of interaction as well. So especially on the East Asian culture, it is appropriate to pass the device using two hands, using your multiple hands. And there could be another contextual level that we can think about in designing interaction. Great question, I think.